Welcome back, everyone, to Data Science for Everyone. Today, we're going to be talking about JavaScript basics. Let's get started. So first off, we're going to be looking at the basic ingredients of what make up any JavaScript program. We're going to talk about the fundamental units of JavaScript code that are going to allow you to represent values and give instructions to the computer. We're also going to look at how to assign a name and to a value so that you can refer to it later in your code. So the first thing that we kind of want to talk about is expressions and statements. So these are the basic building blocks of JavaScript, and that is the expression. Now we're going to again open up the Google Chrome and go to about.blank, and we're going to open up the console window in the inspection editor. Now what we want to do, besides looking at expressions, again, that's basically any value, so we can say something like 1, 2, 3. Now, another thing that we can do with this is have an evaluation. So we can also do something like plus 3, 2, 1. And notice a nice thing here is that JavaScript tries to automatically convert that for you and starts to add it in. We haven't even hit enter or anything yet. And we can also, again, put in a semicolon there and hit enter. And now we actually have produced some value, okay? Otherwise, it'll kind of guess. So we can do, again, something like 333 plus 444. And again, notice it kind of predicts out what you want. And again, we can add in something else like 6645. Okay, and again, you can see here it's guessing what it wants to do. Hit enter there again. So let's also maybe go on and I may right click and let's try and maybe clear this. Again, I can use that to clear everything out. Now, the next thing that we want to do is talking about something like compound expressions. Now, we have this expression statement that we had before, so 3, 2, 1 plus 1, 2, 3. And again, that gives us 444. Now, since this actually contains two smaller expressions, again, we have this piece here and this piece here, that is our compound expression. Now, there are examples of the simplest expressions that is a literal, which is a direct representation of some fixed value. So specifically for here, it'd be 321 or 123. And these are what's called numeric literals or number literals. Now, by contrast, okay, we can have compound expressions like we have here. And that, again, is using this plus symbol in here, which is an operator. So, and again, it's not necessarily a symbol. You can't manipulate it, you can't change it. This is just something that is. Same thing if we have the minus sign, or we have the division sign, okay, or we have multiplication. Again, all of these in here are operators. So they actually allow us, any expression allows us to do something within JavaScript. And again, right now you're using it as a calculator. Now, besides, again, we were talking about using it as a calculator. Again, we have, as I said before here, you can see we do multiplication. But we have subtraction, we have multiplication, we have division. And again, here you notice here we have integers, and here we also have floats. Now we can also have order of operations, which again, this is good because again, we're always following the PEDMOS, right? Or whoops, not PEDMOS, PEMDAS. Sorry. And now, and again, what is this? Parentheses, right? Exponents, multiplication, division, addition, subtraction. Okay, so if we do something like 5 plus 11 divided by what? 11 minus 5. Again, that's going to give us 1. But again, if we do 10 here, or we do 110, notice that we have some, I'll just say a little bit of error that can always go into it. Again, it goes to 9999999. With a 6. So again, this is following our order of operations. So it's also helpful, again, if we do, you can put in parentheses in here. And notice that changes things up just a little bit. So again, we can do maybe 1, 11. So notice this changes how things were before. So let me go on and put this here, and let's do 5 plus 11 divided by 11 minus 5. Notice here, okay? These are two different expressions. Again, first we're going to be doing the parentheses, okay? And then we would be doing the division. So again, this here we would be doing what? The addition, the division, okay? Then the subtraction. All right, so now I've talked about it just a second ago, but we also have floating point, okay? So this here is a floating point object, okay? So that has a decimal. And again, this is going to be useful to us again when we're making business applications or whatever else. Again, you have some item that's, let's say you're talking about interest on something, and you have 8% interest. So you have $100, you're going to have 8% interest. That'd be 108. Maybe you wind up having it compounding of something of those sort. And notice here, now this is what squared, 108 squared. Or you could do the whole thing in parentheses, as we had in our other examples. Okay, and be something like 11,664. So again, we have all these nice applications. All right, so this one happens to be not in, this is a float, and this one comes out to not being a float. But again, we can also, let's see what happens if we add in another decimal place. Notice it doesn't actually do anything. It just kind of rounds up and eats out that decimal place. Now, another thing that we can do with JavaScript is bindings. Now, you can associate a name of something to a value. And that, again, that's going to give us, so this is something that's called a variable. So now that, we also have a couple of things. So we would have a var or a variable. We're also going to be talking about a constant, which is const. Okay, and each of these have their uses. So binding a variable is going to allow us to update that variable associated with the name as needed. Now, a constant, on the other hand, is you can't update it. It's going to remain fixed, or as it were, is constant. So first, let's talk about variables. Now, one thing that we have to have is an identifier. And this is, and we're going to create an identifier is also known as a declaration. So binding the name. So in this instance, let's do something like let here. And again, this is utilizing one of the two variables. So we have let and we have var for creating up variables. And we're going to talk about the differences between them now. So the first one is any keyword. Okay. So let's do let is going, and this is also, let is the current preferred method for defining a variable and declaring variables. So, and we'll primarily be using that throughout this course now, as we'll be using let and var as needed. So let's declare a variable, and let's call this cost. Now notice, as I run this, cost is undefined. Now this creates up a new variable called cost. And this let declaration doesn't have a value, so then it is undefined. Now, since we have created up this variable, we can now say cost is equal to, let's say, $20. Okay, and notice now cost is saved in 20. Now, what we used in here, notice we use this equal sign, but in this instance, we call this the assignment operator. And do not think about it as an equal sign. We'll be talking about equivalence and those types of things later on. But yes, it is an equal sign, but we will call this the assignment operator. Now, when we use this assignment operator, it's very simple to, it's similar to like using the plus sign or the minus sign in mathematical operations. The value of an assignment operator is the new value. So here, if I change this cost to equal 15, now cost, notice, is 15. So we're going to be able to utilize this in a lot of different ways. Now we can also do something like this. Let's say let soda is equal to 2. Okay, and I'm going to change cost to, let's say, 3. Oh, so you notice that gives us an error, right? Because I forgot to type in cost is equal to, I don't actually need to use let here. I would say cost is equal to 3. So this makes a little bit more sense. So notice now we have 2 different statements. Okay, we have cost and we have soda. So notice I cleared this out, so we can also still go back and say cost is 3, soda. Oops, did we not define? I probably misspelled soda, didn't I? I put probably E or something. Yes, I did. So let's do let soda is equal to 2. Okay, and now I will clear that out again. So we have our statements. Now, we have this grand idea to be able to utilize these. So now, for example, we can create up let, maybe do total cost is equal to cost multiplied by soda, for example. Now we can do total cost, and notice now we have 6, so we can have an expression mixed in with our variables, and now you can see how valuable this could eventually be. Again, we haven't even added in tax in here. We could add in a tax rate, we could add in a discount, we could add in all kinds of things. So eventually you can create up your own type of calculator with these, which is again probably one of the examples that we'll do later on in the series. So now let's also talk about constants here. Okay, so a constant, again, is something that we don't want to change. So again, we were just talking about a tax rate. So let's do const tax is equal to, let's say, 1.09. So that means that it's a 9% tax rate. Okay, and notice, again, it gives us this undefined, but again, if we type in tax here, notice it is still saved as 1.09. Now, I have a tendency, if I'm doing a lot of constants, I usually put them in all caps so that I know that that is a constant. That's kind of just a kind of a default thing that we do when we're programming. So now we have our cost, right? So maybe we'll change this. Let's do let price is equal to, let's say, I don't know, a soda would be like $1.99. Right? Then we have the quantity. So let quantity is equal, we want, let's say we'll buy 10 of this product. Okay, and then we have our tax rate. So we can still say total cost. And notice here, I don't have to use let because I've already created it before. So let's do what? Again, we'll use our PEMDAS. So we'll do price times quantity, right? And then we'll do multiplied by tax. And that gives us our total cost here of 21.691. And again, later on, we have functions that we could use to round that up or down, however you're wanting it. Now, one issue that we can have here is if I do something like const, let's just call this Q, okay? Notice we get this syntax error because it's missing an initializer in a constant declaration. So that's what this error is. And what it is it wants you to give a value with const. Okay, with constant, because again, you cannot change it after you've created it, so you have to assign that value during its creation. So again, if we say const q is equal to 200. Now look, there's no issue there whatsoever because we did have, it was initialized. Now, a couple other things that we probably need to talk about is naming conventions. So naming conventions when it comes to using these types of code and everything else, we want to have a couple things. Now, you've seen maybe in other places we could do something like Java script underscore is underscore cool. Now, this is snake case. Okay. Now, this is nice in some instances, but in JavaScript we have a tendency to not use this because, again, in some instances you will see that we can do numbers, and we'll talk about this in other ways. But so let's say 12,300. Okay, and so notice here we have this space, this underscore here to keep that number. We can also do that here as well. So we want to make it, 12,300,500. Notice you can use those underscores there as well. And so to kind of keep it clear, we have a tendency to want to do something like JavaScript is cool. Okay, so this is something is joined to what's called camel case. So we have, notice they have these big capital letters for each word there and that humped. Now, another thing that we should know is that age, and age, all of these variables are different. So notice here I can do let age, I can let age be defined. And notice I can set age is equal to 2, age is equal to 5, and age is equal to 23. Notice I can assign each of these, and that is because JavaScript is case sensitive. Each of these are different. So all underscore or all lowercase age, one capitalized age is a different value, it's a different variable, and all uppercase age is a different variable. So again, this kind of goes to if you're working with people, you can work with them a lot and do different types of things. Like for example, some places I've worked at want us to use snake case only. Now, one of the reasons people don't like to use snake case is that this can be a little time consuming to type those out, but it is extremely clear. Now, use camel case is faster. Okay, so using camel case is significantly faster because you don't have to constantly put in the underscores. But again, that is up to your preference. I would never state whether you should or shouldn't, but make sure that if you do, you are consistent throughout the entire project that you're using. Do not switch between camel and then snake and then some other type of case. Okay, keep it standard the best that you can. Okay. So again, when do we want to choose between let and const? Okay, and again, I'm hoping that it's kind of obvious for you guys, but when you're creating these things, remember let is variable. It can change. Constant is what it is. It is constant and it cannot change. And that is very useful for you to have in your kind of quill of things to use and as a pro. Okay. Let's just say as your toolbox. Now, another thing that we can do is we can have something called increment and decrement. Okay, so let's do something like let and do savings. Okay, so let's say that you have $1,000 in your savings account. Okay, and you can do, if you want to add money to your savings, do savings plus 100. Now, if I do this and I type savings again, savings, notice it stays at 1,000 because I did not do anything. I didn't reassign this. So if we do savings is equal to savings plus 100, now our savings is 1,100. Okay, great. Now, this is a little verbose, to be honest. We would maybe like it to, so let's, again, maybe this isn't a good example to do 100s, but let's say that we do savings is equal to savings plus 1. Okay, and you want to increment it and decrement it by 1. So you can use the increment and decrement by doing this. Do savings, and then here at the beginning of it, you can do plus plus. And notice that is incrementing by 1. Now if I do this again and you look, savings actually, without me running it, actually has 1,102, which is this incrementation of it. Now we can do a decrement, which is minus minus. And notice it is a decrement of 1. So this is nice. Now in this example, we've actually placed the increment and the decrement operators before our variable. Okay, notice they're before the variable that we want to change. Now with the operations in this position though, the output of the increment and the decrement operation is the variable's updated value. So again, when we have the savings and we have plus plus savings, it will change it from 1,101 to 1,102. If we do the decrement in front of savings, it'll do the 1,101. Now, JavaScript also allows for a postfix. So this is the suffix. We can do a postfix. So we can do something like saving plus plus. Okay? And if you notice, it didn't actually go up directly. Okay? But if I do this, if I do savings again, it goes up. So notice it doesn't actually show it initially, but when you look at it again, it'll be that 1,102. So again, just to show you here though, it doesn't do it every time after. Notice it's only the next time you look at the value. So we can do the same thing here. So let's do, let's do savings. 1,102, and if we do savings minus minus, notice the output of this is 1,102, but if we look at the value that's saved internally afterward, it's 1,101. So when we initially initialize savings, the variable with it was initially going to be 1,102 in this instance right here. And then when we use the decrement, okay, it's going to show us what happened before. And then when we look at it again, it'll show us what happened after. Okay. So again, this is very, very useful in adding and subtracting singular values throughout. Now, another way, again, as I was kind of talking to and alluding to at the beginning, when we were adding 100 at a time, we can do something relatively similar. And that is saying something like savings plus equals 100. Okay, and notice that adds up 100 each time. And so again, we can do this again and again and again. And notice maybe your weekly, or not weekly, but maybe every 2 days you're putting $100 into your account or something. That's going to add up that $100 as we go in. So that's nice. Now, let's say that you also have spending, and so money's coming out of your savings account. We can do savings, and let's do minus equal, let's say 140. Okay, so notice now it's subtracting out 140. We can run that again and again and again, and it'll constantly be taking out 140 out as we run this. So again, we can also do this though, just as we did with others, we can do multiplication and division. So let's do savings, and let's say that we have an interest rate, right? So multiplied by 1.02. Okay, so we can keep, equals. There we go. So notice we add, just as we did before, we have this we had a plus equals, we have a minus equals. That reassigns it inside of the variable. So now if we have a multiply equals, it'll do the same thing. We can keep running this and adding in that multiplication effort that we've been doing. And the same thing happens if we do division. Whoops.